its soils and biochar are still in debate about whether it's going to count for carbon credits in New Zealand, and the UN is much more open to it. We made biochars from food scraps, from paper mill waste, from multiple different species of hardwoods, different species of softwoods, and a number of other materials. And also we produced the biochars at like 4 or 5 different temperatures that were 50 degrees Celsius apart from each other. And it's really, I think it's one of the coolest biochar papers out there, because it shows not just what the quality of the different biochars are, but then we then grew maize in soil in a glass house with all of those biochars and measured how it affected plant growth. And I hooked up funnels to the bottoms of the pots and collected all the leachate water that came out, so that I could determine which biochars were best at holding nitrogen in the soil and reducing nitrogen leaching into groundwater. So you can make biochar from anything that will burn, but typically you only want to make it from things that would make good compost or clean wood. So this is a picture I took of my old boss, Johannes Lehman at Cornell, and this is in a field trial that I started for him in 2007. And it's a long-term field trial in New York State, just a few minutes from the Cornell campus. It's on a very large research farm that Cornell owns, and that they will own for eternity. And it was such a great opportunity to start a biochar field trial there, because I tested it and monitored it while I was working there. But since I graduated and moved on and left, every year students and researchers are going back there and monitoring this site and seeing what the effects are 10 years out, soon 15 years out. And so that's just a picture of my old boss's hand pouring some biochar onto the unamended soil. And here's another one where he pulled maize stalk out of the ground. And this is soil that had been amended with biochar already. And you can see the dark parts of the soil that are biochar mixed together with a nice clay soil. So this is just a detailed photo of the biochar that we used in that field trial. And this biochar arrived to us in metal barrels, numerous large metal barrels. And this biochar was made from corn stover. So from the leftovers after corn harvest, the cob and the stalk and the leaves and everything, we wanted to see how converting that stuff into biochar affected the soil compared to letting those same materials rot in a neighboring plot. And the results were interesting. It was beneficial. We did all kinds of application rates and methods, and it did no harm in any of the circumstances, but it did help. It did benefit in certain ones. When you think of charcoal, you probably think of like charcoal bricks or lumps for the barbecue. And that is what charcoal made from wood looks like. If it's big chunks of wood put into the kiln or machine to make charcoal, that's what it comes out as. But if you make charcoal from corn stover, maize stover, this is what the charcoal ends up looking like. And it's a very fine powder. Once you put it in the soil, it's there forever. And that is a very good thing. Like imagine if you could apply a compost that was good forever. That's a lot of what this is comparable to. The benefits of compost, the benefits of biochar choice. They're almost the same. And when you compost biochar or add biochar to a compost feedstock and compost them together, it makes them both better. And some German colleagues of mine published exactly that, going back as far as 2010, and it's just been shown all over the place to be true ever since then. That yeah, if you mix biochar with your compost, it makes the compost better in terms of its effect on the plants in the soil, and it makes the biochar better, because when biochar is produced through combustion, there's a combustion oils and stuff that are on there. Even if you're using like mace stover or wood, like there's combustion products that form like an oily film. Like if you look at this stuff under like an electron microscope, there's a film on very fresh biochar, unless it's been treated, and the microbes eat that stuff right up in compost. So it encourages the microbes to grow in the compost by feeding them, and on a microscopic scale, charcoal biochar looks like an apartment building for microbes. It's just like if you took a piece of wood, and you can do this with like wood charcoal and look at it closely, the cell walls are still there, but the insides have all been obliterated by heat. So it's just like an apartment building for microbes, and they can colonize it, and they can hide in there, and they can leave to like get food, and then go back in there. And a lot of the biochars that I've worked with are made from manures. If you dry a manure, and so in U.S. systems, in agricultural systems, it's much more common to separate solid manure from the liquid fraction for storage purposes, whereas here, farmers have dairy effluent, and it's all kind of stored together as like a slurry. But if you have just the solids of manure, they make excellent biochars because they're full of all the nutrients, nitrogen, phosphorus, all the micronutrients that were in the animal are there in small amounts in that manure, and that's why, before World War II and like the synthetic fertilizers that came out of World War II technology, before that, manure was the source of fertility for agriculture everywhere in the world except New Zealand, where it was always culturally not allowed to have animal or human manures anywhere near where food is being grown. Yeah, and I've really enjoyed like everything I've learned about Maori culture, and that was one of the things I found initially most fascinating, because I don't know of another place on earth where agriculture was done without animal excrement before chemical fertilizers came about after World War II. It's really something special and unique, and shows a keen awareness of hygiene among people who didn't have like the modern scientific knowledge that they couldn't possibly have had of what microbes were, because nobody knew what microbes were until relatively recently when you could look at them. But so manures make excellent biochars, and they also make excellent additions to biochar. Another use of biochar. I don't want anyone to think that I'm just saying things that are like convenient for what I'm trying to do. Like, I'm doing what I'm doing because I've been working with this stuff so long, and I know it inside and out, and I know what it can do and what it's been proven to do. And so this may sound out there, but it's very true. If biochar is fed to cows or to ruminants, it decreases the amount of methane that they emit and increases the speed at which they gain weight. And that's huge. And I'm really optimistic for what the future in New Zealand could hold with using biochar to address greenhouse gas and climate change issues at a large scale.